Hello. Lewis structures are simple pictures of the atom to highlight the valence electrons of either a neutral or charged species. Let's draw some Lewis structures of neutral species from the periodic table. Lithium is what we're going to start with here. Now, the Lewis structure is meant to highlight the valence electrons. Starting at the center, we draw the atomic symbol Li. This symbol here is, instead of drawing the nucleus or any of the core electrons, we omit all of that drawing because we want the viewer's focus to be on the valence electrons. It's a lithium atom, that's all they need to know. By finding lithium on the periodic table, the valence shell has only one electron in it of the neutral because lithium is in that very first box. So, one dot, and I just put it on the north side, so to speak. That's the neutral lithium right there. Let's draw another one. How about magnesium? That's also a metal and very close to it. The center of a Lewis dot structure is just the atomic symbol. No protons, no neutrons, no core electrons. It's not the focus, the valence electrons. Finding magnesium on the periodic table. It's in the third row, second column over. Being in the second column, there's uno, dos valence electrons. So I'm going to put two dots to represent the two valence electrons. Remember that electrons are negatively charged, so spreading them makes sense. Let's do another one. How about fluorine, a nonmetal? Neutral fluorine, we draw the atomic symbol, letter F, and we find it on the periodic table. Fluorine is uno, dos, tres, cuatro, cinco, seis, siete. 7 valence electrons are in neutral fluorine. So we will draw 7 dots. And I'm going to spread my electrons before pairing them. And there I am at 7. Note carefully the geometry of how I drew those 7 dots. It's as if I'm drawing them as if there's a box surrounding it, and I'm putting them on the edges of the box. Don't put dots in corners or anything like that. It's not that it's technically wrong, it's just not good habit. It doesn't fit the grammar of chemistry. So this is a neutral fluorine atom highlighting the 7 valence electrons of the neutral. Sulfur, another nonmetal. We put the atomic symbol, S, in the center to represent all the protons, neutrons, and all those core electrons. We find sulfur on the periodic table. It is 1, 2, 3, 4, 5. It's the 6th box. So there are 6 valence electrons. So I only have 6 dots out here. That's all I draw. Note again how it's they're each 2 pair. The electrons are on like a north, south, east, west of the compass rose. So that is drawing a neutral valence, a neutral Lewis dot structure. And Lewis dot structures highlight the valence electrons. Now let's write the charged species. Atoms are going to gain or lose electrons until they hit some of their magic numbers. Now, the magic number is a full set of electrons, either 2 or 8, depending on the row that it's in right there. And it's always going to take the path of least resistance. Lithium, let's find lithium on the periodic table. Lithium is likely to lose electrons. It only has one valence electron. So there's always a choice. It can either gain 7 electrons or lose that single solitary electron. So it's going to lose that single solitary electron. Now, if lithium lost that lithium lost that solo electron, it's going to become positively charged. And the onion has been peeled, and that inner shell of electrons is available, is exposed. Now, you can see it written like this with just a plus sign, or you may see it drawn like this, where those 2 inner electrons are now the valence. Magnesium. Finding magnesium on the periodic table. It can either lose dose electrons or gain 6 electrons. It's going to lose 2. Losing 2, giving away 2, is always going to be easier than finding 6. So it's going to lose 2 electrons, become +2 charged. Now, when magnesium loses those 2 electrons, it exposes those inner, when it lost those 2 outer electrons, the next layer inside has been exposed. So you can also you may see it drawn like this. Where the magnesium atom has lost these 2 outer electrons and exposes those inner 8 right there. Both of these are good pictures. This is the one you'll see most likely. Fluorine. Let's find fluorine on the periodic table. Fluorine has 7 valence electrons. So is it more likely to steal 1 or lose 7? It is more likely to steal 1 electron. So fluorine is going to become negatively charged because it gained or stole a negative thing. And 7 plus 1 is 8. So here is our picture of fluorine with a full valence shell of 8, and it has a -1 charge. Sulfur, our final example. Sulfur has 6 valence electrons. It's more likely to steal 2 and become -2 charged than it is to lose 6. So this is our picture of sulfur with its common charge of -2 after stealing 2 electrons. I hope this helps. Thank you.